Okay, so we're going to talk about scientific notation, and the whole purpose or the whole point of scientific notation is to make very, very small numbers or very, very large numbers easier to deal with or manipulate. Okay, so it kind of shows you some examples on here. So on the tops of the pages, you guys can always refer to these examples. I know that these are written instructions and that they're not shown in real time necessarily, but they're a reference, so you could always go back to them. So for instance, on here it shows you how to write scientific notation for 3,200. Okay, and it shows you what the answer is on there and why they had to move the decimal and how they got there. Okay, sorry, that's my dog crying because she can't come in the room. So if you look at here, what you are doing is you're converting standard to scientific. Standard is the way that we normally write numbers, and we're going to write them in scientific notation. The only other thing we'll do is we'll do the opposite, and we'll go from scientific notation to standard as well, so you guys know how to do the reverse of that. Okay? So, this is a help sheet for you that I have posted as well. It tells you written instructions of how to convert from standard to scientific as well as scientific to standard. So we're going standard to scientific first. And these are just directions for you in case you ever get lost and you don't want to rewatch the video, but you want to refer to a help sheet. This is basically telling you what you do. So when you do standard to scientific notation, you have to move the decimal point. And remember that if there's not a decimal point, you place one at the far right at the end until your number is between 1 and 10. Count the number of times you move the decimal point, write out the number, okay, and then multiply it by 10, and then put an exponent on the 10 power as far as how many steps you move the decimal. If you move the decimal to the left, the exponent will be positive. If you move to the right, the exponent will be negative. So let's see that in action, okay? So, let's look at these first problems. 625, okay? There's no decimal here, so I place my decimal at the end. 625 is not between 1 and 10, right? So let's move towards a spot where we can get it between 1 and 10. Is 62.5 between 1 and 10? No. Let's move it again. Is 6.25 between 1 and 10? Yes. 6.25 times 10, okay. And then the next thing you do is you write how many times you move the decimal. I move the decimal 1, 2 times, so 10 to the second. And that's my answer. That's all you got to do, okay. I move the decimal left, so my exponent was a positive 2. But as it says on here, if you move the decimal to the right, the exponent would have been a negative 2 instead, because you would have been converting from a small number, okay. Let's see it some more. I know number 2 is over here, but I'm just going to go down this way instead. 49,603. Is 49,603 between 1 and 10? Absolutely not, right? So again, my decimal goes at the end. I'm going to move it once. Is that between 1 and 10? Not even close. Is that between 1 and 10? No. 49.603. Is that between 1 and 10? Still no. 4.9603. Is that between 1 and 10? Yes. 4.9603 times 10, because that's just the way you always write it, your number between 1 and 10 times 10. And then again, I count how many times I move the decimal. 1, 2, 3, 4. So times 10 to the 4th, because I moved the decimal to the left. Okay? Let's look at one more like that. So, 18,569. Again, I'm going to place my decimal at the end. Move it until it's between 1 and 10. 1.8569 times 10, because that's the way I always write it. Count how many times I moved it. 1, 2, 3, 4 times 10 to the 4th. Again, it's a positive 4 because I moved it left, not right. You guys are going to have multiple days to do this. You have 3 days in total. There's about 8 pages, I think. So as long as you do 2 to 3 pages of scientific notation practice a day, you're doing what you're supposed to be doing. If you want to do it all at once, that's fine too. But I've spaced it out over 3 days so that you guys can just do a bit each day to practice the concept, rewatch the video as needed. Let's show you some different ones. Okay. We're going to look for when we're doing the opposite. So let's look at here. Let's say I have a small number instead. So let's look at that. All right. Is 0.0259 between 1 and 10? Absolutely not. So I'm going to move this decimal that's already placed back until it is. 0.259. No. 2.59. Yes, that's between 1 and 10. 2.59 times 10. I moved the decimal how many times? 1, 2. Times 10 to the second. Now in this case though, I moved my decimal to the right, not to the left. So it's 10 to the negative second. Let's see that again. 0.315. I need to move the decimal so that's between 1 and 10. 1. Now it is. 3.15 times 10. I moved it once so I could put to the first. I moved it again to the right, not to the left. -1. Whenever you're starting with something that's already below number 1, it's always going to be a negative exponent. If it's bigger than 1, it's always going to be a positive exponent. Same thing as I said, if you move the decimal left, it's positive. If you move it right, it's negative. Okay? That's how you go from standard to scientific. Now let's look at it the opposite way. Let's say that we want to go to scientific to standard. In my opinion, this is actually easier. So let's look at the rules I wrote for you. Look at what exponent is being expressed. Move the decimal point that many steps. If the exponent's positive, move the decimal right. If the exponent's negative, move the decimal left. Write out your number, fill in the empty spaces with zeros. Okay. 8.6 times 10 to the 3. My exponent is a 3. It's a positive 3. That means my number is going to become bigger, so I'm going to move my decimal to the right. 1, 2, 3. There's 2 empty spaces here, so I would fill those with zeros. My answer is 8,600. And you could always check this with a calculator to see if the math is correct, see if you did it right. You could just type the equation into a calculator and you could see if it's correct. 3.042. 10 to the positive 2. It's a positive 2, so my number is going to become bigger. If it was negative, my number will become smaller. So I'm going to move my decimal to the right. 1, 2. However many spaces it says on here. 304.2. Let's look at another one. 9.10 times 10 to the third. 10 to the third. So I'm going to move it 3 spaces. It's a positive 3, so my number is going to become bigger. I'm going to move my decimal to the right. 3 spaces. 1, 2, 3. There's a blank here, so I fill it in with a 0. 9,100. Let's look at number 16, because that one sometimes confuses students. 9.8 times 10. That's the same as 10 to the first, right? So I'm going to move my decimal once to the right. 98. Let's look at it if it's a negative exponent. Okay. Number 9. 2.9854 times 10 to the negative 1. My number is negative, so my number is going to become smaller this time. So I'm going to move 1, but I'm going to move to the left. 1. 0.29854. Same thing up here. 9.63 times 10 to the negative 3. It's negative, not positive. So again, my number is going to become smaller. I'm going to move to the left 3 times. 1, 2, 3. I have 2 blank spaces, so I'm going to fill those with zeros. 0.00963. Watch these examples again if you need more practice or if you don't understand what's going on. Again, you can always reach out and ask me for help if you need it. Your goal is to practice about 2 to 3 pages of this per day. That's why you have 3 days to do all of these, so that you know what you're doing for scientific notation for when it comes time to test. Okay. Have a good day.